Recording in progress.
Hello, dear students. This is your Engineering Mathematics 3 lecture. Today's topic. Now, here we are going to start third unit, statistics. Statistics, it is the application of mathematics, pure mathematics. Now, the first concept in statistics, measures of central tendency. When measurements are taken on phenomenon, means when measurements are taken on any experiment, it is observed that observations have a tendency to cluster in some part of the range, usually the central part of the range. This tendency is known as central tendency. There are 5 methods of finding a measure of central tendency. The first one is arithmetic mean, second one median, third one mode, fourth one geometric mean, and fifth one harmonic mean. So these are the methods to find the measure of central tendency. In these 5, arithmetic mean gives more accuracy. So in day-to-day life also, we use arithmetic mean to find the central tendency. Now, the first concept is arithmetic mean. Means we are going to discuss about arithmetic mean only here. See, when the data is in the form of ungrouped data, means only the variables or the observations are given. When only observations are given, it means that every observation is appearing at once. Means the frequency of every observation is 1 in that case. See, if x1, x2, x3 up to xn are n observations, then the mean is equal to, the formula to find the mean is equal to, its notation is x bar is equal to summation xi upon n. Means you do the addition of all the observations, n number of observations, and divide it by n. So you will get the arithmetic mean for that n number of observations. Okay, when the data is given in the form of frequency distribution, means it is also called group data. If xi are the class marks and fi are their respective frequencies for I is between 1 to n, then the mean is equal to, means suppose n observations are given, x1, x2, x3 up to xn, and the corresponding frequencies are also given, f1, f2, f3 up to fn. Means x1 is, for x1 the frequency is f1, for x2 the frequency is f2, and so on. Then how to find the mean in that case? The formula is x bar is equal to summation fi xi upon summation fi. Means summation fx upon summation, you in simple way you can say summation fx upon summation f. This is the formula to find the arithmetic mean. Okay, here note that we can write summation f is equal to n also, capital N also. This is also the notation for summation f, means the total frequency, addition of all the frequencies, it is equal to capital N. Notation is n, capital N, remember it. Now the next concept, dispersion. Meaning of dispersion is scatteredness. To find whether measures of central tendencies are true representative of the data, we calculate dispersion. To measure the scatteredness of data from the mean, we use 2 methods, mean deviation and second one standard deviation. There are 2 methods to measure the scatteredness of the data from the mean deviation and standard deviation. In these 2, standard deviation gives more accuracy, so we are going to discuss only standard deviation, and the notation for standard deviation is sigma. See, to measure the scatteredness of the data from the mean, we use two methods, mean deviation and standard deviation. Now, what is dispersion? Dispersion, meaning of dispersion is scatteredness. To find whether measures of central tendencies are true representative of the data, we calculate dispersion. Okay. So here, using standard deviation, we are going to measure the scatteredness of data from mean. Means we are going to check whether the average calculated for the given n number of observation is good average, or it is bad average, or it is the best average. We are going to conclude about the average, which we have found for the n number of observations. Okay. Standard deviation, the notation is sigma here. See, for ungrouped data, what is the formula to find the standard deviation? For ungrouped data means only the n number of observations are given, x1, x2, x3 up to xn, and frequencies are not given. It means that every observation is appearing at once only. So it is also called ungrouped data. Now see, what is the formula to find standard deviation? It is equal to under root summation xi square upon n minus summation xi upon n whole square. Now this summation xi upon n is nothing but the formula of arithmetic mean. It's square, and first term summation x square. Xi square means, you in simple way you can say summation x square upon n. N means number of observations. Now for group data, sigma is equal to, means standard deviation is equal to, the formula is under root summation fi xi square upon summation fi minus summation fi xi upon summation fi whole square. In simple way, you can say the formula is standard deviation is equal to sigma is equal to under root summation fx square upon summation f minus summation fx upon summation f whole square. This is for group data. Okay. So this is the formula, you remember it. Now, there is one note. The square of standard deviation is called variance given by sigma square. Sigma is the notation used for standard deviation. If you take the square of standard deviation, it is called variance. Second note, the coefficient of variation is given by CV. Coefficient of variation, it is given by, is equal to sigma upon arithmetic mean into 100. Sigma means standard deviation. Standard deviation upon arithmetic mean into 100. This is the formula to find the coefficient of variation. Now the example, calculate arithmetic mean for the following frequency distribution. You have to just calculate the arithmetic mean. Now the data is given in the form of frequency distribution, means it is group data. Observations are given 1, 2, 3, 4, 5 observations, and for these 5 observations, the corresponding frequencies are given here. Now you construct the table to find the arithmetic mean. First column is x, second column is of frequencies, and third one is the multiplication of frequencies and observations, f into x, because we are going to find the arithmetic mean here, and here we require the term fx, f into x. Now you do the addition of all the frequencies, total frequency summation f. Summation f is also noted by capital N. So capital N is nothing but summation f. It is equal to 35. To do the addition of all the frequencies, it is 35. Summation fx means the addition of all the values in this last column, fx. It is equal to 3893. Now the formula to find the arithmetic mean x bar is equal to summation fx upon summation f. Summation fx is equal to 3893 upon summation f is, means summation f means n, the value of capital N. It is 35. Here the value 35. You do this calculation 3893 upon 35. It is equal to 111.2286. So this is the arithmetic mean for the given data. Now next example. Calculate arithmetic mean and standard deviation of the following frequency distribution. Now the data is given in the form of frequency distribution, means the group data is given here. Now you find the arithmetic mean as well as standard deviation for the following distribution. Now you construct the table. The first column, X, number of observations. Second column, the corresponding frequencies for the observations. The third column is here, F into X, F into multiplication of F and X. Now, then the fourth column is X square. And the next one is F into X square. Means X square means you find the square of observations. That is your that X square column. And Fx square means F into X square column. And in last you do the total, means you do the addition of all the terms, so that you will get summation F, summation Fx, summation F of X square to calculate the arithmetic mean and standard deviation. Now see what is the formula to find the arithmetic mean. It is X bar is equal to summation Fx upon summation F. Now what is summation Fx? It is 91. So put here 91. Summation F, it is 27. So put summation F is equal to 27. Calculate it, 91 by 27, it is 3.37. So this is the arithmetic mean, 3.37. Now you calculate standard deviation. The formula to find the standard deviation is equal to sigma is equal to under root summation Fx square upon summation F minus summation Fx upon summation F whole square. Now this summation, second term is summation Fx upon summation F. This is nothing but your X bar and its square. So X bar is here 3.37. You just do the square of 3.37. First term summation Fx square upon summation F. Summation Fx square is here 359. So put summation Fx square is equal to 359 upon summation F is here 27. So put summation F is equal to 27. Now you do the calculation. Under root 359 upon 27 minus 3.37 whole square. We calculate the value, then the standard deviation is there 1.3925. So this is a small value, sigma is 1.3925. So that average is average calculated 3.37 is good average. If the value of standard deviation is very large value, then in that case, the average is poor. This is your conclusion about arithmetic mean from the value of standard deviation. You remember it. Here, calculate standard deviation for the following frequency distribution. Decide whether arithmetic mean is good. See here, the data is given in the form of class intervals. Wages in rupees earned per day. 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60. And the corresponding frequencies are given. Number of laborers are here in 0 to 10, it is 5, 10 to 29, 20 to 30, 15, 30 to 40, 12, 40 to 50, 10, and 50 to 63. Now you construct the table to find the arithmetic mean and standard deviation. So here, the first column, wages earned in class interval. Wages earned in the form of class interval. It is given here 0 to 10, 10 to 20, up to 50 to 60. Now, second column, you take the mid value of this class interval. Means for 0 to 10, the mid value is 5. You just divide 0 to 10 by 2, you will get the mid value. 10 to 20. Addition of 10 and 20 divided by 2, you will get mid value 15. Addition of 20 and 30. And then you divide it by 2, you will get mid value 25 and so on. For 30 to 40, it is 35. 40 to 50, it is 45. 50 to 60, it is 55. Means when class interval are given, then in that case, you find a mid value. That will be the observation column. Then the corresponding frequencies are here. 5, 9, 15, 12, 10, 3. Already it is given in the example. The data is given. Then the next column is F into X, frequency into the observations column. Then next is X square column. And then the last one column is F into X square. To find the standard deviation, we require these last two, X square and F of X square, means F into X square column. Now you do the addition of all the terms so that you will get summation F, summation Fx, summation Fx square. Now the formula to find the arithmetic mean is here. Summation Fx upon summation F is equal to. Now summation Fx is here 1567 upon summation F is 54. So you calculate the value. It is 29.0185. So this is your arithmetic mean. Now the standard deviation, the formula is here. Sigma is equal to under root summation fx square upon summation f minus summation f of fx in summation fx upon summation f whole square. So this bracket term summation fx upon summation f is your arithmetic mean. Calculated it is 29.0185. You take the square of this term and summation fx square is 4 times 50 upon summation f is 54. So you just do the calculation of this term and it is nothing but sigma is equal to 13.6612. It is sigma is 13.6612. It is a big value, 13.6612. So here your conclusion is sigma is quite a large value. So arithmetic mean is not a good average. Here your conclusion, because it is a big value, 13 point. In previous example, it was in previous example, the value of sigma standard deviation was 1.3925. It is a small value, so that arithmetic mean is good here in this data in second example. But here in third example, the arithmetic mean is 29.0185, but the standard deviation is a big value, 13.6612. And so it is a large value, quite large value. So arithmetic mean is not a good average. So this is your conclusion. So these are the examples on standard deviation, arithmetic mean and standard deviation. So this session is over here. Thank you.